Hi, I'm Amanda Olson, and this is Math 2410 at MCC. We are looking at problem number 8 from section 5.5. So we're asked to find the derivative of f of t equal to t to the 3/2 times log base 4 of the square root of t plus 9. So when I first look at this, I see that I have a product of two functions of t. So if I find the derivative with respect to t, I'm going to have to apply the product rule. Part of applying the product rule involves finding the derivative of log base 4 of the square root of t plus 9. Just want to kind of make a comment on that. Keep my variable at t. It's very common to want to switch it to the x variable. So if I'm differentiating this, just this term, and we'll look at the other term in a second here, or not term, but the other factor. So if I'm just differentiating this factor, the typical way that I would do it, just if I just didn't do any equivalence, I'd have 1 over t plus 9, and then times ln of 4. And then because this isn't just t, it's a function of t, we'd also have to multiply by the derivative of the inner function. And so that's going to be a 1/2 t plus 9 to the negative 1/2 power. Then you can also multiply by 1, which is the derivative of t plus 9 with respect to 1. So if we simplify that, we get 1 over square root of t plus 9. I'm going to put that 2 out front. Natural log, well, actually, let's put the 2 natural log 4 out front. 2 natural log 4 square root of t plus 9. This square root, or this t plus 9 to the negative 1/2 power, that's also going to be a square root of t plus 9. And so this is going to become 1/2 the natural log of 4 square root of t plus 9 times square root of t plus 9. That's going to be a t plus 9. So that's one way that we can differentiate it. If you look at the way that the textbook did it, they did it slightly differently because they got rid of that 1/2. There's a couple different ways that you could do that. You could recognize that ln of 4 is 2 squared, and then you could bring the square down and have that 4 power. There's a lot of different ways to do that. So if this is the way that you differentiated, that's okay for that one fact, for the specific factor. But just know that the textbook does something a little bit different, and there's not really any right or wrong way to do this. So let's just kind of explore. So I'll show you what the textbook did when they differentiated. So of course they had the f prime of t, and they took that first term. So this is equal to 3 to the t to the 3/2. And then to differentiate this term, you could either write it as we did here, or if you wanted to be able to cancel out that, if you didn't want that 1/2, what you could have done at the start is you could have brought that 1/2 over to an exponent. So in other words, if I'm looking at dt of log base 4 of the square root of t plus 9, this is going to be equal to, now I haven't differentiated yet, so that differentiation notation is staying present. We get that 1/2. And now I can use my rules, my properties of logs to bring that 1/2 out as a coefficient. So then this is going to be the derivative with respect to t of 1/2 log base 4 of t plus 9 that 1/2 can stay out front. And then when we differentiate that, we get the log derivative. We have 1/2 over t plus 9 times ln of 4. So you get the same result. It's just kind of a matter of how do you want to present it. And then after that, there's, multiple things you can do. So let's go back over here then. So I have the derivative of the second term. So this is going to be 1 over 2 t plus 9 natural log of 4 plus, and hopefully I can kind of keep these separated. I didn't really leave myself enough room, but this is going to be the derivative of t to the 3/2. This is going to be 3/2 t to the 1/2, and then just times the log base 4 square root of t plus 9. All right, and then, we're welcome to just leave it like that. You could use some properties of exponents to kind of rewrite this. That might be a little bit of what you see in the text, so they kind of factored out some common terms. But as it stands, this is a perfectly acceptable answer. It just depends on, I guess, how you want to write it. So that's it for this one. All right, thank you.